Good morning, everybody. My presentation is about this 5G SCAS project. I presented this project 2 years ago, actually at BMSB in Calgary. And well, I have only 15 minutes, so I will try to focus actually on the current situation in 3GPP and try to explain what's really going on in 3GPP and what could happen in the next years. Then after the coffee break, there is one session with several technical papers of 5G SCAS, so you can have some more details. So I will start explaining a marketing trap of 5G and why this 5G level is a bit misused today for many different topics. And then I'll explain the status of 5G broadcast in 3GPP, and I'll explain a little bit about the 5G SCAS technical solution and an outlook on what can happen the next steps. So what happened in 3GPP is that the initial plan a couple of years ago was to submit LTE also as a radio interface for this IMT 2020 process, which is the official 5G level, this process by the ITU. And then, if you're familiar with this IMT 2020, there are 3 types of families of communications: enhanced mobile broadband, ultra-reliable low-latency communications, and massive matching type communication. So the idea, you have it there, is that basically release 15 of 3GPP, this new radio covers enhanced mobile broadband. Ultra-reliable low-latency communications is covered by new radio release 16, which is currently under development. And you have there the trap. The trap is that massive matching type communications will be actually covered with LTE IoT, so that's narrowband IoT, or LTE-M. And well, at that time, when release 15 was about to start, so 5G, the 5G specifications were about to start, then LTE IoT was release 14. So the decision that was taken in by 3GPP was that the 5G level in 3GPP will be release 15 and beyond. So, that meant, of course, that narrowband IoT, release 14 at that time, wouldn't qualify for that 5G level. But if in narrowband IoT there were some small modifications in release 15 or release 16, then immediately that will qualify for having this 5G level. So actually, this situation is what later on has affected 5G broadcast. And actually, as we saw yesterday, there is this funny term of LTE-based 5G broadcast that I will continue explaining later. So what's going on in 3GPP? First of all, a bit of terminology. In 3GPP, there are 2 terms for broadcast. Now we have this terrestrial broadcast that we can say it's the traditional terrestrial television mode, so downlink only, receive only devices, free to air, etc. And then the mixed mode broadcast, that's supposed to be that's more from a mobile network operator point of view, the capability of dynamically switch from unicast to multicast or broadcast when needed, when there are many users. So I'll stick with these 2 terms. And also, before starting the specifications of release 15, that was release 14, there was a very important milestone for broadcast in 3GPP was the specifications of this LTE NTV, also known as FEMBMS, and which is actually the first, for the first time, a broadcast mode is fully specified in 3GPP. So that means, again, downlink only, free-to-air, receive-only mode, and so on. This release 14 specification has some issues, like, well, and some of them, they were presented, for example, last year at BMSB. This non-SFN signaling, it is known that the spectral efficiency is poor compared to ATSC 3.0, for example. And there are some limitations regarding the, well, cyclic prefix of the OFDM symbols and the subcarrier spacing. But nevertheless, there are, well, broadcasters interested in just being able to get to mobile devices, and they acknowledge that even with not having the most efficient transmission standard is not so important, actually. So 1 year ago, in plenaries of 3GPP, it was the release 15 was finished, and then it was decided what to do regarding broadcast in release 16, the ongoing release in 3GPP. And basically, what it was decided was to do exactly the same as with IoT for broadcast. So it was decided, you have it there, that to continue or to enhance this LTE NTV from release 14 in release 16, so that the NTV will have this 5G level. So that's where the point where 3GPP starts talking about LTE-based 5G broadcast. And then, well, it happened there were some vague requirements that I will show next about what broadcast service will be in 5G. And then it was decided to take a look to those requirements, check if NTV release 14 met those requirements, and if needed, make some modification. But of course, it was clear from the very beginning that some modification was needed, because otherwise, release 14 doesn't have this 5G level. And well, on the other hand, this mixed mode, multicast, broadcast, that was decided that it will not take place in release 16, but it will be one topic for release 17. So, well, so what is actually happening right now, this release 16, is that NTV, release 14, has been cross-checked against these requirements. And, well, I won't get into details, but basically there will be some modifications regarding the subcarrier spacing, numerology, maybe or hopefully regarding the signaling as well. But as you can imagine, I mean, in one slide, you cannot have all the requirements from broadcasters. Like if you, well, think on ATSC 3.0, the commercial requirements, DVB-T2, and so on. It just happened that, well, at that time, these requirements were designed before starting the specifications of 5G. It seems that there were no broadcasters were not or didn't get to include their requirements, actually. So what is going to happen is that this 5G, LTE-based 5G solution is addressing some broadcasting requirements, but they are not really like detailed. So, so here just, well, to illustrate what's going on right now, so we have actually two tracks. We have the LTE track, and in release 16, which is taking place now, you have this LTE-based 5G terrestrial broadcast work, which is a small amount of work compared to the mainstream, which is the development of release 16 for the new radio and the service enable core. And well, this new radio in release 15 and 16, it's only unicast, so there is no multicast or broadcast yet. But actually, as it seems today, there are very good chances that this new radio mixed mode takes place in release 17 that will start next year. And actually, so, well, basically in 3GPP, the main areas of work is the RAN and the core network, and the core network has already a study item ongoing to analyze how to enhance the 5G core to have multicast broadcast. And then just a comment, this the terrestrial broadcast variant of new radio will not happen before release 18. So that's already clear. So at the earliest, it will happen in release 18. Okay, so well, now that you know a bit what has happened in 3GPP in the last 2 years in a very quick way, and I'll give you some details on 5G XCast. And well, for those of you that are not familiar with the project, we started 2 years ago. Actually, in Calgary, 2 years ago, I presented the project, and we had just started. We have been the first project to start working on 5G broadcast, talk about the broadcast slicing and so on. So it's a European research project. There is this 5G PPP framework that somehow covers all the research projects on 5G in Europe. And well, the goal of the project is to design, or actually in the project, because we are finishing next month, we have designed the broadcast and multicast components for 5G. The vision that we had 2 years ago was like regarding convergence. You have it here. This is actually the same slide I showed 2 years ago, but it's basically that users should not care about the technology that is being used to deliver content, and that 5G is actually an opportunity for the convergence of fixed, mobile, and also broadcast networks. And of course, here is key to have this seamless, uninterrupted experience. In the project, well, we have done a lot of work, and we have covered from use cases, test beds, but basically, well, regarding 3GPP contributions, we have been working, of course, in the RAN, and we have covered the air interface, the RAN architecture, the RAD protocols, and also the core network. And there we have been also working in this converged core, like to be able to have this fixed, mobile fixed and broadcast network. Regarding the design principles that we follow, basically we try to minimize the extensions. So we try to minimize the additional features to have multicast broadcast compared to release 15. The release 15, I mean new radio and the service-enabled core. And basically, the whole idea was to hide the broadcast delivery feature from both content providers and users. So multicast broadcast, or in a more general term, point-to-multipoint delivery, should be a delivery optimization tool of the network. So users, they don't care if it's they receive the content via point-to-point or point-to-multipoint. And even the service provider also should not care about that. And well, in the design process of the project, basically, we have followed this three-phase approach. So first, going from 5G unicast to 5G multicast broadcast, it will be this equivalent to this mixed mode using 3GPP terminology. And there we have tried to have, we have aimed for a generic and flexible solution for point-to-multipoint distribution that is valid for all verticals. So for media, V2X, IoT. In LTE, there are different multicast broadcast solutions, actually, for those verticals. So we have actually, well, we aim and we manage to have a single framework, point-to-multipoint framework, for all those use cases. And then in a third step, we have made some extensions for terrestrial broadcast, because terrestrial broadcast, assuming downlink only, no uplink, free to air, so those specific features, then of course they are not applicable to other verticals. And well, actually 3GPP is, we'll start working on this soon, but most likely seems that it will take this three-phase approach as well. And here, well, I just wanted to show you an example of how this design approach has been applied regarding the 5G core network. So you have here in the left the unicast 5G core network. What I've done is first to extend the core network to this mixed mode, or to have multicast broadcast. We have tried to minimize the additional features in order there to support multicast broadcast and to have, of course, a 5G friendly solution. So we have defined two network functions, one for the control plane and one for the user plane. Then later on, in the third step for terrestrial broadcast, we have, in this case, well, remove unnecessary network functions and, well, if needed, of course, define some additional features. Well, from a 3GP point of view, the most important work that has been done in 5G XCAS is this air interface, the RAN architecture, and the core network. There will be, as I said before, one session after the coffee break with some of the results. Other than that, in the webpage of the project, we have basically published already all the results. And we are right now accepting reviews from external reviewers so that we can, well, improve basically the deliverables in this month and next month when the project officially finishes. But basically, as I showed in the previous slide, we have extended the 5G core to have multicast broadcast. We have enable the RAN architecture to make single frequency networks. We have extended the air interface to have point-to-multipoint transmissions. For terrestrial broadcast, for example, there is need for longer cyclic prefixes, and in order to have single frequency networks in high power, high tower networks, we have also extended that. And, well, many more things that I cannot explain in one single slide, but just you get a picture of what we have been doing is to, if you're interested, look at this air interface, RAN architecture, and the core network. So what's the future from my point of view regarding 5G broadcast in 3GPP? We have this LT-based solution that is being worked on currently, and the goal is to complete it in March next year. So we will have this LT-based NTV solution in release 16. This will be officially the 5G broadcast solution in 3GPP. There will be some small adjustments, as I said before, but from a spectral efficiency point of view, the performance will not be comparable with state-of-the-art standards like ATSC 3.0, but nevertheless, there are broadcasters interested in these solutions, and at the end we have this problem that you need the broadcast delivery technology to be implemented in mobile phones, or and there are some major vendors which are eager to implement this LT-based solution. Regarding this the new radio and the 5G core, there is no multicast support in release 15 and 16. Although in release 16 we have this non-3GPP access that Mark showed in his presentation. And when considering 5G as a system of systems, that gives room for more access technologies to join the 5G space and the 5G level, actually. But in 3GPP, there are right now good prospects for the 5G the mixed mode to happen in release 17. And 3GPP will actually follow the 5G-SCAST approach to have a single point-to-multipoint delivery framework for all verticals, media, V2X, IoT, mission-critical communications, and so on. The work on the extension of the 5G core has started in last March with a study item in SA2. The work item in release 17, I checked yesterday when preparing the presentation, that has been approved actually already. There is a plenary, RAN plenary this week, but RAN hasn't approved yet any study item on new radio multicast broadcast. But on the latest, it should be decided at the end of this year. But again, so it seems as of today that this mixed mode will happen in release 17. And as I explained, new radio terrestrial broadcast will not happen before release 18 at the earliest. So, and then, well, 5G-SCAST will finish in the next month, but a very solid and efficient technical solution has been designed. And actually, because we have been the only people working on this in the last 2 years, we have received a lot of attention, and even from big 3GPP players. So, well, some people sometimes ask me, is 5G-SCAST going to make it to 3GPP? Well, the project is finishing, but definitely the solution that has been designed in the project will be the reference point or the starting point for all 3GPP work that is coming. And most likely, this approach that we have followed in 5G-SCAST to design first a generic point-to-multipoint extension of 5G, this will be this mixed mode, and then later on extension to terrestrial broadcast will be followed also in 3GPP. And that's it. I think I made it on time. And there is plenty of information in the web page as a public research project. All results are published in the web page. And as I said before, we are now waiting and looking for feedback from external people to the project to improve the deliverables, because in this month and next month. So if you have any question, well, please attend the next session on 5G-SCAST, and if you have any question, just let me know. Thank you.